7.5 talks about our first trigonometric ratio, which is the tangent ratio. So we will use the tangent ratio for indirect measurement. To start off, we are finding values of variables in these right triangles. Number one, which variable do you want to start with? Okay. What's the name of the trick that we would use for finding x? The heartbeat trick shows us the proportion that we should set up to find x. So what would that proportion be? Okay, we could do 6 over x equals x over 4. Cross multiply, we get x squared equals 24. To get x alone, we would have to square root both sides. We should get x equals 2 root 6. We also need to find y. There were a couple different names for the trick to find y. My favorite trick or name for the trick is to call it a boomerang method. You have to start on part of your hypotenuse near the leg. So we're going to start at the 6. We're going to swing around that leg that we're looking for and then back along the whole hypotenuse. Okay, so we started here at the 6. So 6 goes over y, and then we went back along that leg. So we have y over the whole hypotenuse is 10. Okay, again, cross multiply and solve. Y squared equals 60. To get y alone, square root both sides. If we simplify that radical, two root 15. Okay. Questions about either part of number 1? Okay, number 2, we actually have one of our special right triangles. Which one is it? It is isosceles. I thought I heard somebody say it, Kara. Good, 45, 45, 90 triangle. Because it is isosceles, if those sides are the same, then these two angles have to be the same. Therefore, the only measure they could have is 45 degrees. Because it's a special right triangle, we have some equations or formulas that we can use to find missing sides. We only have one equation that's associated with a 45, 45, 90, and that is that the hypotenuse is equal to what? A leg times root 2. What are we going to plug in for h for this triangle? 30. Our hypotenuse has a length of 30. What did they use to label a leg? X. Root 2. To get x alone, what would I do to both sides? However, we cannot leave a radical in the denominator, so we have to rationalize it. I'll show that down at the bottom. To rationalize it, what do I do? Good. Multiply by root 2 over root 2. I'm not entirely sure what you mean. So these root 2's cancel, and I'm trying to simplify this. Yeah, it's still there.
Well, I'm not saying it's supposed to be on top or not.
Yeah.
Okay.
What,
I was like confused because down there it doesn't have that.
because we're not dealing with the x. The x is going to be alone now. I'm just trying to rationalize this.
Oh, yeah.
Do we have any other questions? Are we all understanding how to get a variable alone? Okay. In order to rationalize, we multiply top and bottom by the square root of 2. In the numerator, that gives me 30 root 2. What do I get in the denominator? What simplifies? Okay, 30 over 2 simplifies to 15, multiplied by root 2. So, x equals 15 root 2. And that is my final answer. What questions do we have? Okay. Note a trigonometric ratio is a ratio of the lengths of two sides of a right triangle. We will use trig ratios to find missing sides and missing angles of right triangles. So today we are only dealing with one trig ratio, which is tangent. The tangent ratio. Let triangle ABC be a right triangle with acute angle A. The tangent of A, written T-A-N, capital A, is defined as follows. The tangent of A is equal to the length of the leg opposite angle A over the length of the leg adjacent to angle A. So right now we don't have those legs labeled. Frequently, legs in right triangles get labeled with the lowercase letter of the letter that is from the angle opposite that side, which we've seen that before. Okay, the side that's opposite the right angle, we would call that the hypotenuse, is going to get labeled with a lowercase c for this triangle. The side that's opposite or across from angle A, we would label with a lowercase a. And the side that's across from angle B would get labeled with a lowercase b. It does not have to be done this way, but traditionally, sides across from angles are labeled with the same letter, but angles have capitals, sides have lowercase. Questions about how we labeled this? Okay. Again, it doesn't have to be done this way. This is just kind of a traditional way of labeling it. We could have labeled the sides X, Y, and Z if we really wanted to. So if I'm looking to find the tangent of angle A for this triangle, even though we abbreviate it when we write it, we don't abbreviate it when we say it. So regardless of what this looks like, it is pronounced tangent of angle A. Okay, tangent of angle A is equal to the length of the leg opposite angle A. What leg is opposite angle A? Okay, lowercase a, little a. Over the length of the leg adjacent to angle A. Lowercase b. Okay, so opposite, I'm hoping at this point we already know, means across from. Adjacent is going to mean next to, but it cannot be the hypotenuse. Okay, we will talk about using the hypotenuse when we talk about the other trig functions. Tangent does not use the hypotenuse. So when we say adjacent, we mean next to the angle, but not the hypotenuse. Questions, concerns? Anybody need more time on this slide? Okay. We'll keep going. Find the tangent of S and the tangent of R. Write each answer as a fraction and as a decimal rounded to 4 places. To start this problem, we really don't need a calculator. We will need one to do our decimal form, but for the fraction form, we don't need a calculator. If we are finding the tangent of angle S, that means S is my current reference point, or reference angle. Tangent is opposite side over adjacent side. So what side is opposite angle S? 80. What side is adjacent? 18. That will reduce, so we should reduce it. What does it become? 40 over 9. So there it is as a fraction. Then they also want it as a decimal, so in your calculator you would just take 40 divided by 9. It said rounded to 4 decimal places. 4.4444. Okay, that would be rounded to 4 places. So that's the tangent of angle S. They also asked for the tangent of angle R, which means that we are shifting our reference angle to be R. So now, when I try to find tangent, I'm looking for the side that's opposite angle R, which would be over the side adjacent, is 80. This would reduce to 9 over 40. And then as a decimal rounded to 4 places. Okay, so there aren't 4 places, so that's fine. 0.225. If you really want to, you could put another 0 on the end. You don't necessarily have to. Did I what? Yes, because if you have 80 over 18, you're talking about the tangent of angle S, not the tangent of angle R. So we do have to be careful about these and be consistent with what they're asking for. Other questions? Okay, let's move on. Find the value of x. Now, in my opinion, these notes go kind of from like 0 to 60 real fast. If you are trying to find tangent of something, that something is always an angle. So next to your trig function will always go an angle. Since we've only learned one trig function so far, that's going to be the one we have to use. This time, what did they give us as our angle? 32 degrees. So that's what goes next to your tangent. Trig functions will always be next to an angle. Equals. Now we can kind of treat this like we did the last one. We want the side that's opposite over the side that's adjacent. What's opposite the 32 degree angle? Over what's the adjacent side? X. When we go to solve these, we are going to treat them like a proportion, which means I need both sides to look like fractions. So I'm going to take the tangent of 32 degrees and put it over a 1. Now it looks like a fraction. I can cross multiply and solve. One of my cross products is easy. What's one of them? 11 equals x times the tangent of 32 degrees. Tangent of 32 degrees represents a number, So even though it doesn't look like just a number right now, it represents a number. So what could I do to both sides to get x alone? Good. We can divide both sides by the tangent of 32. Tangent of 32 represents a number, so we can divide by that whole thing to cancel it out, and that would get x to be alone. I understand this is probably different from any math you've really done before. Do we have questions about it right now?
If we don't write this in instead of 32, is that wrong?
Like, you don't show me what you're doing on both sides?
Well, like, I just wrote the 32.
That would be wrong. 32 and the tangent of 32 are two very different numbers. If your work doesn't look like my work right now, it's probably wrong. You could have flip-flopped these sides. You could have x times tangent of 32 equals 11 instead. That's really the only way it should look different. Here is where you absolutely have to have a calculator. In many calculators, you could type this in just as you would read it out loud. 11 divided by tangent button 32 equals. Some calculators you cannot enter it in just as you would read it out loud. Namely, the calculators that I have that are like black and gray with a green second button. Those ones are a little funky. So before we get to calculator questions, what did we get typing this in for those of you that were able to? Let's round to the nearest tenth. 17.6. So round to the nearest tenth on these ones. Now, I'll pause for a minute to see if anybody has calculator issues or questions. Okay, 2B is going to be a similar setup. Who can raise their hand and tell me the initial equation they set up? Ari? Good. Tangent of 17 degrees is equal to 9 over x. Opposite over adjacent. The tangent of 17 gets put over a 1 so that we can cross multiply. 1 times 9 is 9. We would also have x times the tangent of 17. In order to get x alone, we need to divide by the tangent of 17. Okay. Then we go to our handy dandy calculator. Set in degrees, entering it in carefully. What do we get to the nearest tenth? 29.4. Did anybody not get 29.4? Or need help getting there? All right, find the height of the flagpole to the nearest foot. They didn't label the flagpole, but we could label it with a variable since we don't know what it is. What variable would you like to use? Okay, I heard A first, so we'll go with A. It does not matter to me what variable you use. So A's fine with me. Who wants to tell me their initial setup for this? Somebody other than Ari. Brianna?
Tangent 65 equals x over 24.
Good. Tangent of 65 is equal to whatever your variable is. XA over 24. Opposite over adjacent. The tangent of 65 gets put over a 1, so that way we can cross multiply. One of our cross products is easy. What is it? A or X, your whatever your variable is, equals the other one is 24 times the tangent of 65. Now, I am being very purposeful in how I write this. I would not at all recommend writing tangent of 65 times 24. Yes, multiplication is commutative. However, if you type it into your calculator, tangent of 65 dot 24, and press enter right away without using extra parentheses, you're not going to get the right answer.
Negative root 3.
Yeah, it's not right. This doesn't work. Now, if you were to type it in tangent of 65, close those parentheses that your calculator opens, and then type in your times 24, then it would work. However, to avoid this issue altogether, I would put the 24 times in the front. Because if you just type it in 24 times tangent of 65, you don't have to worry about those parentheses at all. Are we picking up what I'm putting down? Okay. So if you really feel strongly about putting the times 24 at the end, you have to remember to close those parentheses that your calculator opens up. If you don't do it, it's not going to come out right. If we type it in correctly, what do we get for the height of the flagpole?
51.5.
Okay, so 51.468 is what I'm showing initially. What do the directions tell us to round to? The nearest, oh, I didn't put my 151. The nearest foot, so the nearest foot would be what? Careful. 51. Why is it 51? Okay, it's followed by a 4. Don't round it to the 10th and then round it again. We are only rounding one time, and it says to the nearest foot, it's got to be 51 feet. If you were to put 52 feet on a quiz or a test or something like that, you would not get full credit. If you showed me your work, you could earn some points for setting it up, but you would still miss points for rounding incorrectly. Use a special right triangle to find the tangent of a 60-degree angle. Write your answer in simplest radical form. For this problem, you will not need a calculator. Okay. So let's just set up a special right triangle. If we are trying to find a 60-degree angle, then this triangle better be what type? Don't make it hard. A 30, 60, 90. We don't want a 45, 45, 90 if we're trying to find the measure of a 60-degree angle. Right now, we don't know for sure any of the legs or the hypotenuse of this triangle. However, we could label them either way. What is usually the best leg to have on a 30, 60, 90 triangle? The short one, because both of our little formula equation things are based on the short side. So I would label your short side first. You could use an S for short. You can use an X because it's unknown. But I would start with labeling your short side. That would be the one we would be most interested in knowing because the other two are based on that one. If you use an S or an A or any other variable, that's fine. It's up to you. Are we all understanding why I think that's the most important side to have? Okay, so if I wanted to label, for example, the hypotenuse, which we don't really need, but if I wanted to label it, what would it be labeled? If I'm basing it off of the 30-degree angle. How does the hypotenuse relate to my short side? What? It's the biggest. Oh, somebody said it. 2x. The hypotenuse is 2 times the short side. So if my hypotenuse is 2 times my short side and I label the short side x, it ought to be 2x. We getting what I mean? Then we should also label that last side. The long leg is also based off of my short leg. What do you think it should get labeled? X root 3. Okay, because the long leg is the short leg times the square root of 3. Do we have questions about why we labeled it this way?
Where did you get the 3 from?
from our special right triangle formulas that we were supposed to memorize. The long leg is equal to the short leg times the square root of 3. That was in our 7.4 notes. Other questions, concerns at this moment? Okay. So if we are trying to find the tangent of a 60-degree angle, we can use this triangle. Tangent of 60 is equal to what over what? Very good. The side opposite my 60-degree angle is x root 3. The side adjacent to my 60-degree angle is x. What will simplify here? The x's. What happens to them? They cancel out. X divided by x would just be 1. So the tangent of 60 degrees is equal to square root of 3. Again, if you are planning on getting into trigonometry your senior year, this will be an important thing to know. Really, I think you actually have to memorize your trig functions of certain angles for trig. You have to memorize sine, cosine, tangent of things like 30, 60, 45, 90. I believe, if I've heard correctly, that some classes actually get timed quizzes where you just have to have them memorized and fill them out real fast. Questions about example 4?
What is that? How to simplify?
Yeah, that's it. That's all there is to it. I would hope so. Nothing else. Okay. Then that leaves you a little bit of time to get started on your homework or work on those PSAT problems that are due on Friday. Either way, we all have something that we can be working on.